Well, hello, and we're doing another basic building block of code, and today we're going to be looking at libraries. It's a really, really important one. So, with our libraries themselves, one of the key things about coding is it's great to reuse code, but and that's the code you write yourself. So I've got an efficient way of repeating the same set of instructions, and I want this robot to repeat the same set of instructions. That's great, but actually there's another thing you can do, and that's even a bit cheeky, but you can reuse other people's code, and that is exactly what we're going to be looking at today, is reusing the code that other people have written. Now, you might think, well, hang on, seriously, is that wrong? Well, sometimes people want you to use their code. They've come out and they've given it to the world. That's very generous of them. And it's like, don't reinvent the wheel. I'm not going to reinvent the wheel. I'm going to let somebody else do the hard work for me. And if they're generous enough to give me that code, then I'm going to say, thank you very much. That's really kind of you. And I'm going to use it. I'll kind of give you an example of how this could work. So imagine we've got a scientist, and the scientist is stuck with a really complex problem, and she's going, I'm not quite sure how to deal with this. So what's she going to do? Well, of course, she's going to look it up. She's going to get her book and go, aha, I get where I went wrong. It wasn't a mystery after all. I just needed a bit of help from somebody else that's done the work. So it's no longer a mystery. Thank you very much. The answer was staring me in the face all along. It was 42. There you go. So she's used the help of somebody else's text, somebody else's library. She's gone to the library, she's found the book that gave her the answer, and it's doing all the work for her. That's the kind of thing that libraries are. Is they're other documents, but they're documents of code, and we can ask our program to look it up to find out how to do things. So that's what we're going to really look at when we use code. So where does this come from? Well, we use import, and import is a special line of code that we will actually put at the top of our code. So the kind of languages that can use import, probably the one you've come across already, well, that would be Python. But you may also have come across, if you've come across it yet, Java. Now, in both of these ones, the word you use is import. And then you add the name of the code, or the name of that library that you want to import. In some cases, the name will actually be its location on the web as well. Now, that's not the only method that can use to import it. Is other languages such as Visual Basic. Visual Basic you can also import. There would be less, because that's now, particularly as it's assumed into Visual Studio, which is actually quite a large package. And Visual Studio comes complete with an enormous inbuilt library of codes inside its integrated developer environment. However, even there are still sometimes you'd want to import, and in that case you don't write the word import, you write the word imports. So a huge change, and then you add the name. And I've just chosen the three languages that we'd be covering most: Python, Java and Visual Basic. And they all use imports from time to time. Okay, so when we're doing this, where do we get the common uses? Well, with something like Visual Basic, what we're really looking at is probably extended mathematical functions is one of the main ones. So you'll be looking at maths functions, and they're more advanced ones. The kind of stuff that you normally wouldn't be writing in Visual Basic or visualbasic.net. Python, which you've come across, well, some of the ones you might have seen, drawing the turtle around the screen. So you've got turtle. If you actually want to make your Python work with some kind of window form, well, those forms have been pre-written in libraries, so there's Windows forms. And maybe you're writing your Python to work on the internet, so you'd have different web applications. And of course, another one, something like Pygame, you'd be using games. If we're looking at Java, well, actually, with Java, you're looking, in fact, at all of the above. But there's a few notable additions. Probably one of the biggest ones that's had the most impact would be writing in the background applications of operating systems. So the largest one there, what I mean, is Android. If you want to actually program Android games and applications in the same way that you download a library for Windows Forms with buttons and everything else, well, you can download a library that has the entire connectivity of all the Android mobile phone devices on there. You don't need to program them, it comes automatically. It's very similar to software like Greenfoot, where you don't have to program the game world. That comes for you, just import the library. With Android, you just go import android.star and you have everything you need. In some cases, these libraries, in fact, have been linked into the developer environments. So in the same way that Visual Studio contains all the basic libraries of Visual Basic, you could actually get Android Studio. Now, that's still writing mostly in Java, but the first line you'll see put there by default is import Android. So you don't have to write all the nasty techie and that nasty technical languages. That's all being given for you. You just need to use the code the way you want. Now, why would we use these kind of things? Where's it leading? Well, when we think about it, there's some massive advantages. The first advantage is when you're using your programming environment, whether it's something simple like Greenfoot or something complex like Visual Studio, is it's much more lightweight. So there's less of it. So the first thing I'd say you would probably say the advantage is your developer environments, whether it's an SDK or an IDE, they are lightweight. So they're fast to run, they're flexible. And because they're fast and flexible, what we're doing is we're doing a massive thing called future-proofing. What do I mean by that? Well, you've got your code and you've got your environment, and then somebody comes across with a new mobile phone. What do? Well, you download the new library for that new mobile phone, and you can keep using the same code, and you can keep using your same favorite software for coding it. But now, all future developments, the things you haven't even thought of yet, well, you can now program for them just by importing the new library. So it's future-proofing. Another way of saying that would be it's extendable. When you're looking at particularly Java, there are more common libraries that you can have access to in Java than anybody could ever remember all of them. Is one of the things that people find difficulties with. They say, I will never learn all of this. And the trick is, no, you never will learn all of this if you're a Java programmer. You will learn what you need to learn. And you download the libraries that you need. You learn what the commands are, how they use them. But you don't need to know how they're made. You just use them. And that's it. So they're very, very extendable. But then that leads to the disadvantage. And here's kind of the biggest disadvantage of all is you will never know all the code. It's like the internet itself. It's out there, it's uncontrolled. So you may come across uncontrolled code. Now, programmers aren't stupid. They've already actually looked at that, and there are certain areas where they have tried to introduce a level of control, a level of centralization, a level where one organization is taken upon itself to actually say, here we have a set of code that works, and if you use our code, then you know that these common libraries are always going to work and they're safe and they don't contain viruses or anything.